Hi everyone, my name is Haddad. I'm in the Faculty of Civil and Environmental Engineering in the Transportation Department, and I am the head of the T-Smart. And today I would like to share with you some of the research that we do at T-Smart Lab. But before, let's look at the future. This is one of the Swiss banks, how predict the future in Zurich 2050. So in addition of autonomous vehicles, of course, we have a smart system, smart infrastructure, and also we have smart or autonomous robots that can help you to do the shopping. Now, it's clear that we have new technologies, new communication and information technologies. Actually, some of these technologies are already integrated in the transportation infrastructure. And in the future, we will have also autonomous and connected vehicles. All these type of technologies eventually will create new interactions. New interactions, not only human and human, but human with autonomous vehicles. And with these new interactions, we are expecting to rise some systems which are very complex, what we call system of systems. In our lab, we want to face these challenges of the future city traffic by combining two things, the traffic flow theory and the control theory, by doing and developing some models, describing more dynamics, more multimodal dynamics, and to introduce some control strategies which are autonomous and robust and adaptive. How we do it? This is our research vision. So we distinguish always between two levels, one network level and then the lower level. And we have the scheme of two schemes, one of hierarchical scheme. So first we deal with the network level and then we go to the lower level. And each level, we have the closed loop. Of course, everyone will know what is a closed loop. So we have the models, we have the monitoring, we have estimation, and the control strategies, etc. In order to do this, we need data. So we initiated a real sensory network in Tel Aviv. We installed 100 Bluetooth sensors, and we collect the data. We send that data through Bluetooth to Borovich building, and we have this system that collects the data, and we can utilize this data in order to model micro simulation of the network of Tel Aviv, and then calibrate this with this Bluetooth data. Finally, we end up with investigating at the macro level the relation between the number of vehicle density, the number of vehicles in Tel Aviv, and let's say the average flow in this city. And this nice graph show you a relation that as you increase more vehicles, of course, the average flow increases in the city of Tel Aviv, but after a while you have congestion, and then this will decrease the productivity of the city. So with such modeling, you can utilize it in order to do some control. Of course, for example, this is a perimeter control. You can coordinate between the traffic signal lights on some border of some region in order to manipulate the flow, to meter the flow entering to the region, such that you can regulate the number of vehicles around this set point in order to maximize the flow. And eventually, you end up with some strategies without smart strategies, with smart strategies that we develop, that you can protect the city. And this is what the next 5 years or next year, I think, they will do with the toll of Tel Aviv. When you enter, you need to pay 25 shekels per day. So this is type of strategy that can be implemented in order to protect the city and to have less congestion in the area. Now, what's wrong? Okay. It got stuck. Oh, sorry for that. Okay, so this is at the macro level. No. That's it. Maybe I should not show the other one. That's it. Jump on slide. So it's this one. Okay, yeah, that's it. So this is at the individual level where you implement some new algorithms because we install the Bluetooth sensors in California, sharing here in the Bridge of Jerusalem, and here also in nature. When you go turn right to go to the Technion. And then you can, because you have different type of sensors, which is Bluetooth and Bluetooth detectors, you need to invest or to do some algorithms, new algorithms, and these algorithms are implemented for the first time in the world, how you can integrate Bluetooth sensors from mobile phones to estimate the traffic and to change the traffic lights in real time. Now, once you do this, you have what we call hierarchical control, because first we talk about parameter control, we consider only regions, but then we go to the lower level with the one that I show you in Jerusalem and in nature, and then you can maximize the throughput because you do hierarchical control. Now, there are some other research in autonomous vehicles that we do. For example, there are many research that has been done for autonomous vehicles platooning. In our lab, we are considering some algorithms, state-of-the-art algorithms, mostly theoretical algorithms in the literature in order to see if it's working in the lab, in order to decrease the complexity of online sort optimization. And this is one of the TASP students in the past. Another TASP student did is that imagine that you have in the future roads without lanes. So imagine that now these are roads with 2 lanes. You don't consider the paint of the lane channelization in the road. And then, because it's the future, if you have autonomous vehicles, you can better use the weights of the road. And also you can do a larger curve and you can increase while you are moving the curve. Once you do that, the question how this will affect the network of the transportation network. And we see that we can increase, depending on the scenarios, depending on the settings, etc., between 5 to 20% improvement in traffic flow and capacity only by changing these simple rules, delete the links. Now, I will make it short. For the last 4 years, we are doing a huge project with Google, Greenlight project. And here, what we did an automated system for traffic signal optimization. So it's like Waze, we collect the data with the probe data of Google that you are using. We can estimate the performance of the system. We can estimate all the traffic signal lights at the intersection without any data from the city. And once we have all this data, we send an email to the city suggesting modification of the traffic light. Increase green here, decrease green there, and you can improve the system. All this automatically done and has been implemented for more than 100 experiments in the world, all over the world, with the main focus of Google research about CO2 to decrease the emission. This is a nice project. Another project that we did with another physicist with UTAM as TASP, also taking into account how we do a safer urban rail system where we control the passenger flow at the platform in autonomous train. So this was nice that you show that with control, you decrease the number in the stations in order to make it safe, but still maximize the throughput. Cyber attack, we are from Israel, of course. We need to consider this, and we have several papers, how we can do a robust system for traffic signals under cyber attack. And then the last question, what about the coffee? Because I didn't really care down about coffee. I just registered now for barista. So this is, again, the banks, it's the same bank expect that the drone will bring coffee to you and to utilize your time in a better way. But this is not 2050. It's already in China.
And we are in the middle of a park, and we are about to have some drinks dropped off by a drone. I have never experienced anything like this.
So I will have this. with other researching that
So the delivery has
you
landed
consider
right in there. Let's see,
Oh, sure.
brought my Starbucks to me in the park. All I need to do is type the last 4 digits of my phone number and I should be able to get it. Let's have a look.
So there are other labs that take into account every other space for the land, etc.
Oh, the special delivery box is pretty cool.
Okay, but we focus about drones with in terms of this one is not working. Yeah, this one is not working. In terms of drones, so imagine that in the future we'll have many drones in the urban airspace. How you manage that in terms of traffic flow point of view, capacity, etc. We have several researches that has been done, many research in terms of modeling and control. We end up even with a simulation that does not work. I don't know why, but maybe. We end up with a simulation of tools to design to help transportation engineer to determine where is the 30 ports and how this affect the delays waiting at the 30 ports because the sky is congested, etc. This is a long-term research, but we are on that. So please join us if you like more research, and sorry for the time.